Hello and welcome to this Haas tip of the day. What makes a G82 spot drilling cycle so special, different than a regular G81 drilling cycle, is its ability to dwell at the bottom of a hole. So, when should we dwell at the bottom of a hole? How long should we dwell for? Does it matter? Well, the answer might surprise you. I've spot drilled this hole, but haven't dwelled at the bottom. I used a regular G81 drilling cycle, which goes straight in and immediately back out. It looks great to the eye, but if I blew it using layout fluid and cut it again a little bit deeper, we can see that the part doesn't clean up all the way around. Without a dwell on this drilling cycle, my spot drill doesn't even make one full revolution at the bottom of this hole. That's going to leave an uneven surface. It's not even going to clean up. An uneven surface with a spot drill is bad. But if you're cutting valve seats on a cylinder head, or if you're trying to get a nice seal surface with a port contour cutter on a hydraulic manifold, you might end up with an uneven surface. That could cause leaks. You might end up with a bad part. Here, we have a tool that isn't even making it one full revolution. We used a G81 with no dwell. This will give us an uneven floor surface finish. This dwell is too short. Here, we have used a G82 cycle with a 1 second dwell. 1 second doesn't sound like much, but at our RPM, that leaves the tool rubbing the part for more than 30 revolutions. This will cause our tool to wear out quickly and can ruin our surface finish. This dwell is too long. Now here we have our perfect Goldilocks dwell time. This dwell is just right, not too short, not too long. We've done the math and commanded a P dwell. That's enough to fully clean up the surface, but not so long that the tool sits and rubs excessively. On aluminum, dwelling too long isn't so bad. I mean, it wastes cycle time, but the burnished parts will probably work just fine. Harder materials like steel, titanium, and even powdered metal valve seats are way less forgiving. They don't like dwell times that allow the tool to rub. When a tool is rubbing, it's going to wear out quickly, and it can also ruin your surface finish. So, this is why we've got our perfect Goldilocks dwell time formula written out for you. Here's how it works. Our dwell revolutions, is the number of times the tool is going to make a full revolution at the bottom of the hole. 60,000 is just a conversion factor. This is because there are 60 seconds in a minute, and we want our formula to work in milliseconds, not seconds. RPM is just the S code, our RPM value in our program. And G82 is our spot drilling can cycle with a P value. This P value is what our formula is trying to get us to. A P 1.0 equals 1 second. That's a 1 second dwell. But so is a P1000. If our program uses a decimal point, then the control is going to read this dwell in seconds. If our P value does not have a decimal point in it, then the control is going to read that as milliseconds. Now, most of our dwells are going to be really small. To make a 2 revolution dwell on most parts is only going to take between 15 and 300 milliseconds. So we're going to end up using a P15 to a P300. That's a normal amount of time for a dwell. When a human eye blinks, it usually takes between 300 and 400 milliseconds. Not long. So our entire dwell time literally happens within the blink of an eye. Now for our port contour tool, I want to go with a 1.5 revolution dwell. So I'm going to put in 1.5 into our formula. I'm going to carry down this 60,000. That's just our conversion factor. My RPM on my port contour tool is 2,000 RPMs. That's S2000. So if we did the math, this would give us an answer here of 45. That means that in my program, I'm going to command a G82. We're going to use a P value of 45. At 2,000 RPMs, my port contour tool is going to dwell for 45 milliseconds. I'm not using a decimal point. 45 milliseconds, which is going to give us 1.5 full revolutions of dwell, which is plenty to clean up our part. 45 milliseconds. That's our perfect Goldilocks dwell time at 2,000 RPMs to give us our 1.5 full revolutions. 0 milliseconds was way too short. 1 second dwell, way too long. Well, the next time you run some counter bores, counter sinks, ports, or you're just spot drilling, remember to calculate that Goldilocks dwell time. Your programs aren't going to take any longer than necessary now that you're going to be using short dwells, and your tools won't be rubbing, which means they're not going to be wearing out any faster than they need to. If I'm just going to break the edge of an existing hole, just putting a chamfer on a hole with my spot drill, I typically don't dwell at all. I'll just use a G81. Now dwells, the p-values don't work with G81 cycles. But on a side note, did you know that those dwells can be added to your G83 PEC drill cycles? You can dwell at the bottom of those holes as well. Well, like always, talk to your tooling vendor about your specific application and play around with those dwell revolutions to figure out exactly what your part needs. Check your programs, do the math, and shorten up those cycle times by using very small dwells, milliseconds, not seconds. Well, thanks for letting us be a part of your success and for watching this Haas Tip of the Day.